This is a video recording of Chapter 1, Section 6 in the 7th grade textbook entitled Variables and Algebraic Expressions. Okay, so we learned in the last section how to make some problems easier and to manipulate a problem around, so hopefully I can do mental math as opposed to really straining my brain and doing some tough calculations, or rather using a calculator even. Right? We're going to try and avoid that. This section now is going to throw some of that same ideas in the problems, but now it's going to insert the idea of variables into those problems as well. A variable is an unknown, all right, and that's what we're going to start studying here. That's really key to the next several years of your mathematical lives as you head into algebra. Algebra is really heavily focused on the study of variables and finding values for variables. You'll tend to see this a lot as you go through the next several years. So let's go ahead and look at the definitions here. A variable is a letter that represents a number that can vary. Again, this is, as I defined it earlier, an unknown. We can find it, but as it sits as a variable, it is an unknown. It's a letter that represents a number that can vary. A constant is a number that cannot change. A constant, most of you are going to think of as just a number. So 3. Or 7, or -11. The one thing is it cannot be directly connected to a variable with multiplication or division. So something like 3x or x divided by 7, those numbers are not constants. If the problem said something like x plus 3, however, 3 would indeed be a constant. An algebraic expression is an expression that consists of one or more variables. To you, that's going to look like a mathematical problem without an equal sign. Key difference from that is you're going to all of a sudden have a variable in there instead of all numbers. Again, an algebraic expression is an expression that consists of one or more variables. And to evaluate is to find the value of a numerical or algebraic expression. So really what they're saying when they say evaluate is solve whatever's on your paper. Find the value of a numerical or algebraic expression. So let's go ahead here and start looking at some algebraic expressions and some variables and some constants, and we'll do some evaluating here. In question number 1, they're asking us to evaluate k plus 9 for each value of k. Now, let's give some credence to the definitions we just saw here. K plus 9 is an algebraic expression. Again, an algebraic expression, that's just a problem really. Notice what it's missing is it does not have an equal sign. It's something we're going to simplify here. It's not just any old problem though. It's got a variable in it as well. It doesn't necessarily have to, but it can. In k plus 9, we've got a couple other of the definitions there. K, again, that's our variable. Usually variables are represented by letters. Truthfully, it can be any symbol, but most textbooks stick to just the letters. And 9 is a constant. It's just a number. And again, constants cannot be connected to the variable by multiplication or division. When they're connected, most often we see it in multiplication in our books. Something like 3k, 3 there would not be a constant. 3 is actually what they call a coefficient. Coefficient, simply put, is a number in front of a variable. Again, when we talk about division, we've already talked about division in terms of multiplying by the reciprocal. So when we say connected by multiplication there, we can really mean that for division. Okay, so let's go ahead and do now what they've asked us to do now that we've talked about the different parts there. What they're telling us here in part A is they want k to equal 5. So what that means is you're going to change k into 5 and then solve the resulting problem. Now, if it was necessary here, you would have to apply any order of operations. However, as you can see, this is just a basic problem with one step, so it really don't have to worry about it. We don't have a lot of choices in life here. So I'm going to do 5 plus 9 and get 14. In the B question, they want us to use that same algebraic expression, k plus 9, but instead they want k to equal 2. So I'm going to change k into 2 and solve. So now it's 2 plus 9, which is 11. And now you've evaluated an algebraic expression. Pretty cool, pretty easy. Now, here they're continuing to ask us to evaluate algebraic expressions. The difference is here, now you're going to have to use the order of operations in that process as well. As you can see, what most of you would say is, well, boy, those look like they're a little bit longer. Indeed, they are, because that's why we're going to use order of operations. There are multiple steps involved in solving here. But the process is still the same. In the A example where it says 4x minus 3, they're supposed to change x into 2. So now it says 4 times 2 minus 3. Now, just to make sure you don't make a mistake, remember, changing x there to 2, the way that's written is multiplication. That does not mean now I'm going to write 42 minus 3. It is 4 times x. So it is 4 times 2 minus 3. So of course, order of operations would make me do this multiplication first. So I'm going to do this 4 times 2 first, which changes into 8 as you can see, then subtract the 3, and that's how I end up with 5. In the B example, I've got s divided by 5 plus s for s equals 15. Now, some of you might be flustered by the fact that there are 2 s's there. It doesn't matter. Both of them change into 15. So when we do that, we have 15 divided by 5 plus 15 now. Again, order of operations is necessary here. You know that division is going to come before the addition. So I'm going to do the 15 divided by 5, which is 3, and then add the 15 at the end. 3 plus 15 is 18. In question number 3, they're asking us to evaluate 6 over a, 6 divided by a, plus 4b, 4 times b, for a equals 3 and b equals 2. Well, as you can see, they keep notching the difficulty up on you a little bit here. Now there are 2 different variables, but that shouldn't be of concern to us. Right? There's 2 variables, there's 2 different things you're supposed to plug in there. So you're going to change a into 3. Why? Because they told us a is 3. And you're going to change b into 2. Why? Because they told us b is 2. So now it says 6 over 3, 6 fraction bar 3, 6 divided by 3, plus 4 times 2. Well, it doesn't matter that we had 2 variables that we changed. Now it's a problem with all numbers. Use the order of operations just like we always have. You've got division, you've got addition, you've got multiplication. Well, you know that that multiplication and division is going to come before that addition there. So again, we can work that multiplication and division using the order of operations left to right. So as you can see looking at this question, they did the 6 divided by 3 first, changing into 2. Then the 4 times 2 next, changing into 8. Again, taking care of all the multiplication and division order of operations parts from left to right. And now they can come down here and add and do 2 plus 8, which is 10. Realize if you don't use the order of operations, you're going to get this wrong. Because you're going to do 6 divided by 3, which is 2, 2 plus 4, which is 6, and 6 times 2, which is 12. Well, notice that did not match our answer when we used the proper order of operations. Using the order of operations, no matter what they do here, is essential to coming up with the correct solution. No matter how many variables I throw at you, or what type of problem I throw at you, you still have to use those order of operations. Okay, so let's wrap this up here by looking at the concluding example, which is asking us to evaluate a plus 6 for the value of a. And this problem, they're asking us to change a into 3. So if I change a into 3, it's 3 plus 6. Well, 3 plus 6 equals 9, and that's all we have to do.